Well, good morning, guys. This is a video to follow up on the two previous ones of how the panels are assembled. Last night I worked with this a little bit, and this is one of the completed panels. This is what I was talking about the accesses being cut for the gaskets. Here's an example of one that is not put together yet. That's the accesses for the gases or the fluids. And here's another one here. So when they are completed, you'll have a gas port, for example here, and a fluid intake port here. But on this side it's blocked off. But when you flip the gasket over, you have on the back side gas, fluid discharge, and fluid intake. So they're alternated, as you can see. So basically that's how they look. Now what I'll do is I'm going to go ahead and assemble one and kind of show you how that happens. Basically what I do is first is I of course lay out the gaskets, and one will be faced this way and one will be faced this way. So this one will be put down. Make sure I got my orientation correctly. This will be put down first, and there will be glue applied to these surfaces, and then this will be assembled on the jig as such. It's a little messy when you got glue on. And then you bring a panel over and install that. And they're always a hassle to do with one hand when you're holding a camera. As such, and you keep working it around there. Like such, as you can see. And then the next gasket, you can take your finger and you can kind of feel, okay, the notch is on that one in case you get mixed up, because I do. Then I grab the next gasket cover, and it's laid on top in the reverse of what the other one was. So you can see how that goes. And once that's completed, I have the glue on these. I'll take something like the end of a pin or something like that, and I kind of rub right in there like that to make sure that the fabric gets bonded or the glue's pushed into it in both these. It's a little hard to do it on the other side, but so far it's worked out well. Then I'll grab the top of the jig, and then it's set on. Like such, and compress down, and then I'll kind of move the gaskets around and make sure everything's in place like that. And then I set something heavy on it. In this case it's some shafting, and that compresses everything down. And I let that set for 15-20 minutes with this particular glue. And on occasions, while I have it in the jig, I'll take a razor blade and then I'll trim any excess off that perhaps I don't care for. In this case, this one will be trimmed here on these corners after they're glued, and you just get them all nice and a little more neater. Because when I'm cutting the gaskets, they have a tendency to expand, get drug a little bit, and throws the accuracy off slightly. So that's basically the procedure, and it's just very repetitious. Just keep doing it until you get them all done. So 15 minutes to a half hour set time for the glue per panel is kind of how it's going. So there you go. And once I have all these complete, then I'll probably go ahead and tear down the cell. But I do have some things I want to do with the cell. I have a video on that also. I will dumped all the fluid out. Right now it has KOH at 28%. And according to, well, Bob Boyce, which is the authority on this, but also my research, I want to strip any excess chromium off the plates, 316L plates. And I'm going to do that with a sodium hydroxide. Sodium hydroxide is what's used to strip chrome off chrome-plated parts at a rechroming facility or a chroming facility. So what I'm going to do is pre-treat these plates in sodium hydroxide to strip all the excess chromium off. And sodium hydroxide does not affect the nickel. And at that point I may, depending on what they look like under a microscope, I may go ahead and apply a nickel plating to those plates and then reassemble them after that's complete with these new panels that I have here. And we'll just have to see how things go. And once that's all set up, there's a sequence of how the membranes or the panels are set in, and to keep the gas orientation correctly with polarity of the plates and such. And it takes a little messing around to get that figured out. But once that's done, the cell will be completed and then hooked up with dual bubblers. It actually becomes a dual cell, one for hydrogen, one for oxygen then. But I plan on having a common feed to supply fluid, because I want this to be a convection style cell. It's not as efficient as a true common ducted cell, because you do have circulation and you have some porting that's open, but it is still very, very efficient compared to a lot of the open, well, it is way more efficient than the open bath type scenarios. Although this one's probably a little better than the more on the efficiency aspect than the common average series cell, aka dry cell, which I don't agree with because there's nothing dry about it. So the series cell, and because of the way it's designed, yes, there's some electron migration, but I think it's greatly reduced, because the first cell I did by the numbers, by the amount of power put in versus the gas flow out and such, and taking in temperature compensation and so on, the calculation we used. It was right there. It was within a few numbers of being right at Faraday, so I'm very confident the cell is doing well. And it doesn't run hot, so you don't have a lot of waste going on inside the cell. And I mean by not hot, it runs up to about, let's say 4 or 5 hours of running at 20 amps, 25 amps. I'm running around 100 degrees maybe. And of course the shop is cool now, and that's a factor. But I take that usually into consideration when I'm doing the calculations. So the next video will show that the panel is probably being installed in the cell, and then the following video will show how the cell is set up with the bubblers and the feed tanks and such, and then I'll demonstrate the two component gases and how clean they are comparatively. Hopefully I won't have any bleed through, and it'll work great. So talk to you guys later.